Okay.
You are welcome to our next lesson. Candidates and other viewers outside there, good afternoon. Last time, we had a discussion on sources of light energy. And today, as well, we are not far from the sources of light energy. Only that there are some terms that we are going to use that were not related to the terms that we had at first. Now, when we are looking at our next lesson, you will find that there are basically two terms that we are going to use. And those two terms in our current lesson is luminance and non-luminance sources of light. Now, when we are looking at luminant sources of light are also called direct sources of light energy. These direct sources of light energy are almost the same as the natural sources, but only the term differentiates. So you'll find that these are objects in our environment that are able to produce light energy on their own. You'll find the very examples we gave last time are the very examples of luminant objects. When we talked of natural sources, I believe children that are very attentive outside there, you'll be able to give me examples of natural sources of light energy. So if you happen to give all the natural sources of light energy, you'll find that all of those natural sources of light energy become examples of luminance objects. Why? Because they are able to emit or to produce light on their own. And these are some of the examples. We have the sun, we have stars, glowworms, fireflies, then erupting volcanoes. The major emphasis here when you look at the fireflies must be written as one word, don't separate. When you separate, you have made something very different. So fireflies is one word, glowworms are two words. So all of those ones are natural sources of light. You'll find a simple question can be posed. Why is the sun called a natural source of light energy? Why is the sun called a luminant object? So you'll find the answer that will be given is the same. So you'll find that we went ahead to look at some pictures of those luminant objects. When you look at the pictures, you'll find that we're able to put only those ones that were a bit complicated. You'll find that we have the first one looks like a caterpillar, but that's what we call a glowworm. A glowworm is a lava stage. So you'll find that at night, a glowworm is able to produce a bluish light at its abdomen. And that's what makes it qualify to be called a natural source as well as a luminant object. Why? Because it emits light by itself. The next one is also an insect called the firefly. So many we call them fireflies. So you'll find these ones are called the living sources of light energy. So when we are talking of living sources, you'll find that there are only two living sources of light energy. We have glowworms and fireflies. One is a glowworm, and on the other hand, one is a firefly. Then the other ones I did not illustrate. I believe that we are able to draw. Erupting volcano, you can draw a hill and show it erupting. The sun, we always observe how it appears. So a child can be able to scramble the sun outside there. Stars are very simple to draw. So those one a child can draw by him or herself. When we're looking at luminance objects, we again found that there are objects within the luminance and, let me say, within natural and artificial. that are able to produce light energy when they are still red hot. When they are still red hot. You'll find that for them, they can only produce light energy when they are red hot. Such objects, we call them incandescent sources of light. Incandescent sources of light. Incandescent sources of light energy are those ones that produce light energy when they are still red hot. Or we can say they produce both heat and light energy. Heat comes first, then light follows. So you'll find that those ones, we call them incandescent. A few examples are here. You can check, remember leaving you an exercise of drawing. So a child that drew them very well, I believe you can be able to compare with some few that I've drawn here. You'll find that the first one is burning firewood. Burning firewood. As long as light is there, that means it's able to produce light. So incandescent objects, we find that they are both natural and artificial. So we said we also have objects or sources of light that are both artificial and natural. And they happen to have come with a name called incandescent sources of light. Incandescent sources of light are those objects in the environment that produce light energy when they are still red hot. Or you can say they are materials in the environment that produce light energy, both light energy and heat energy. Some examples of incandescent sources of light. I remember telling you they are both natural and artificial. The sun is natural. Erupting volcanoes, natural. Burning charcoal, artificial. Lighting charcoal stoves. And those ones are common in our homes that use paraffin. So even those ones are artificial. Burning bulb filament, not a bulb that has not been lighting. It reaches a time when a bulb can completely become red. The filament, when you touch, the whole bulb envelope becomes very hot. That means the filament have got burned. So you'll also have burning candles and burning oily lamps. Oil lamps are many. We have what we call lantern lamps. We also have pressure lamps. Some children have smaller lamps made out of metals by blacksmith that only have 1 wick. So you'll find those ones are also called the oily candle. So those few examples are examples of incandescent objects or sources of light. These pictures show some of examples of incandescent objects. I told you we brought those ones that are a bit challenging for you to draw. We have the first one, that's burning firewood. Second one is burning a candle. The next one we have a glowing insect. Then we have those are lamps, bulbs. So they are different lamps. Then when you check it down, we also have the first one is a lamp. Then the second one, that one is a lighting matchstick, and the final one, that one is the sun. So those are examples of incandescent objects. That's their illustrations. So you'll find that as long as they are red hot, when you touch them, you'll find that they burn you and at the same time they light. Next thing is non-luminant objects. Whenever we talk of something non, that means not as real as the first one. So with the non-luminant objects, you'll find that these are objects that do not produce light energy. They are sources of light. But they are unable to produce light. But instead, for them, they are able to make some people realize that they are producing light by reflecting light from other sources. So we say these are objects that do not produce light energy on their own. What they do majorly is to reflect light from other sources. Let's just look at some examples. We have the moon. The moon is a natural object that exists on its own, but cannot produce light, but instead it reflects light from the sun. We also have the mirrors. This one, we have dressing mirrors, they are driving mirrors. All of those ones do not produce light on their own, but what they do, they reflect. We have planets. Planets, we shall see them at large when we are dealing with the optical objects. You'll find that when we are looking at planets, you will get to know the variety of planets. But right now, take it the way it is. Planets are also non-luminants. We have car reflectors. Car reflectors, for most of you whose parents have vehicles, you'll find that a reflector cannot produce light, but it just reflects light as somebody keeps driving the vehicle. Now we have some pictures. Those pictures are few. Why we made them few? Because those are the ones that are very difficult to draw. We have the earth. The first one is the earth. And this one is part of the planets. Part of the planets. But these planets will be seen clearly when we are dealing with the physical planets under eclipse. Now let us leave that and look at the properties of light. Light has a variety of properties. One of the properties light has is light travels in all directions from the source. That means whenever light is produced, it's able to move to all sides from its source, not only one side, as long as there is no obstacle. The second one, light travels in a straight line from the source. Light travels in a straight line from the source. That's why you find at times light can be existing, but at times you will not be able to see. If you happen not to see, that means you are next to an opaque object that has blocked light rays from moving. So light must move in a straight line, but we cannot see in corners. We can't see in corners because light travels in a straight line. The only comparison you can have with the light and sound energy, as light moves on a straight line from the source, sound now travels in all directions from the source. That's why we are able to hear even in corners. Reason being, sound travels in all directions, but you cannot see in a corner because light travels in a straight line. Light travels through a vacuum. Light travels through a vacuum. When we're in our primary 6, we learned about vacuum in relation to states of matter. When we talk of vacuum, vacuum is a space without any state of matter. You can't see gas, you can't see solid, you can't see liquid. So it implies that for the case of light, light can pass even that space without matter. But if you are giving comparison, you'll find that sound can't again travel through matter. Reason being, sound needs a mode of transmission. It needs media for transmission. But light does not need a media. That's why it travels through vacuum. The speed of light can be interfered by some materials or media. When we talk of materials that can interfere with the speed of light, you'll find that there are materials that cannot allow light to pass through them. Light cannot pass through them, and those materials, we call them opaque objects. So you'll find that opaque object interferes with the movement of light. Another object that can disorganize the movement of light are translucent materials. Translucent materials allow little light to pass through them. And finally, we have materials that can allow all the light to pass through it, and those ones we call transparent materials. We shall look at them later. Light can be reflected. Light can be reflected. Then light can be refracted. Those two terms almost look alike. You'll find that to reflect is to bounce, whereas to refract is to bend. So that means light can be bounced. Light can be bounced. That's why at the start we are talking of non-luminous objects. Objects that cannot produce light, but they are able to confuse the people at their also sources. Why? Because they reflect light from other sources. So for them, when light reaches there, it bounces. Then their work is to send it to those ones who feel like using it. So reflecting is bouncing, whereas refracting is bending. We are going to have all of these properties discussed one by one, but because of time, let us first have the first one shared. Experiments in properties of light. We want to start with the first property that states that light travels in all directions from the source. When we are looking at that property, what we need to have to prove that light can really travel in all directions from the source. There are some few materials that you must have in your experiment in order for observers to see really light travels in a straight line. One of the materials needed for a child to have, we can have an experiment where a child wants to prove that light travels on a straight line. Somebody can have an experiment of having dry cells, having electric bulb, then having a conducting wire. Materials needed. Okay, I've started with the different one, but all those materials are here. Let us start with the one that we have on our notes. We have the first one. You should look for a candle, burning a candle. So this burning a candle should be able to light. There is a bit of mixture, don't mind. I will rearrange for you. There is also electric bulb, a matchbox, batteries or dry cells, conducting wires. Then procedures. Let us start with the one of using a candle. So this is what we are going to use, a waxy candle. A person or a child carrying out this experiment must get a candle first. Get a matchbox, That matchbox must contain matchsticks. That matchbox must contain matchsticks. Now, what you do with the first one? You first arrange. You are supposed to arrange this your candle. This candle, you get a matchbox, lit it. After that, light your wax candle. After lighting your wax candle, you will be able to observe that even if you view from the west, north, south, or east, you will be able to see that light is clearly seen. That one tells you that light travels in a straight line light travels in all directions from the source. The next experiment is of dry cells. Experiment is of dry cells. Now with the dry cells, we are going to use electric bulb. You get your electric bulb, arrange the batteries, then you connect the batteries using a conducting wire. This is how you do it. Get your batteries, arrange them, ensure that batteries has two ends. We have what we call a negative terminal and a positive terminal. Every battery or every dry cell has two ends. So what you ensure that a negative terminal must be joined to a positive terminal. So this is what a child does. Now we are saying after that get your bulb. After getting the bulb, join using a conducting wire. So this is what you do. Put your conducting wire, then join using the bulb. So you can be able to see that the bulb is lighting. When the bulb is lighting, it shows a child that light travels in all directions from the source. After that, a child now is expected to complete the circuit. Once you complete the circuit, you'll now have these illustrations, then. These observations. If you happen to join your dry cells and there is no light produced, that means you do not arrange the dry cells well. The dry cells were poorly arranged. So in our conclusion, we have observed that if you happen to light a candle in all directions, you are able to see light. If you arrange dry cells well, after your bulb lighting, in all sides you are able to see light. That one tells you or proves that light travels in all directions from the source. Now this activity is very simple. I want a child who, through the very notes, within those very notes, you are going to give me the similarity between light and sound energy. If you are very keen when I was explaining, I want to see one similarity between light and sound energy. Question 2, you have to write 2 examples of incandescent objects. Question 3, why is the moon not a natural source of light, yet it exists naturally? And the last question, you carry out an experiment using 2 dry cells, an electric bulb to show that light travels in a straight line from the source. With that, children, I would like to wish you a very lovely day. But remember that COVID is our threat for now. Ensure that you wash your hands. The order of the day, sanitize your hands. And ensure that if the face mask is at home, ensure that you put on them whenever you are discussing with your neighbors or people whom you don't trust. Thank you very much.